Hey guys, welcome. This is 2.5 video. Anything that you see, you need to write down. Okay, so I'll be telling you what we're writing down. We're actually getting into proofs, and proofs are quite an easy ordeal for most of us because all we have to do is just explain what we're doing. So we're just coming up with reasons for things that we already do. What I'd like you to do is you can get this from your book too. This is on page 113, as you can see kind of here in the bottom corner. But we need all these definitions. Addition property, subtraction property, multiplication property, division property, reflexive, symmetric, transitive, and substitution property. So go ahead, if you can, pause the video right now and copy these down. Okay, I'm assuming that you've got these down now. Let's go ahead, and we got to copy a little bit more down. So let's go ahead and move on to the next piece. We are talking about distributive property. Now, distributive property, again, it's a take note box, so I only want you to take note of this box, so please write down this box. So I'll go ahead, pause the video, and get that down. Okay, I'm assuming you got that down. Again, we should know a lot of these properties already. We're just kind of getting refreshed in our mind. And we'll take a look at the last one. This last box we don't need to actually write down, but this is properties of congruence versus properties of equality. We can go back and forth, and we'll talk a little bit more about these, but we already actually wrote down for these three already, so we don't need to actually write these ones down. Okay? So, like I said, proof is what we're talking about, and all proof is, it's a convincing argument that uses deductive reasoning. Okay, and we're going to be looking at, more specifically, a two-column proof, where we're going to list statements on the left and reasons for each statement on the right. Okay, and so this is kind of an example of what it would look like. We don't have to write this down. You're good. But we have a given, we have a proof. Sometimes we'll have a picture that accompanies it, and we're going to make statements, basically show our math, and then we're going to go ahead and give our reasons. So it's kind of like we're just showing our work, and then we're doing one extra step, is we're saying why we can do each step. Okay, so proofs are not that difficult. They get a bad rap because they just take time, that's all. Okay, so let's go ahead and let's do our first example together. Okay, so let's go ahead and write this down. Example 1, given 5x plus 1 equals 21, prove x equals 4. So normally in algebra class, we'd go ahead and just say, alright, all you have to do is this problem right here, and once you get to the solution, you're good. Okay, in geometry, we're actually giving you the answer, x does equal 4, but now I want you to show me how you know that. Okay, so I've already done some of the work, right? We get 5x plus 1 equals 21. Notice then we become 5x equals 20, and then we get x equals 4. Okay, so that would be the work we would show. Now we want to write the reasons. Now the reasons are going to be all those properties we wrote down. Okay, the very first thing, how did I get 5x plus 1 equals 21? My favorite thing is the very first thing that you see is usually given to you. So what's your reason? Well, it's given. There's nothing really that special about it. Next, how did I get from step 1 to step 2 is what I want to ask myself. How did I go from 1 to 2? Well, it looks like there was a 1 on the left side and now it's gone. Well, how did I get rid of that 1? It's probably because I subtracted the 1. Okay, if you actually go back to our rules over here, subtraction property shows A equals B, then A minus C equals B minus C. So as long as I subtract from both sides, we're good. So what I do from step 1 to 2, I subtracted. So what is my reason? We would say subtraction property. Okay, and I'm going to shorthand with prop. Okay. Number 3, how did I go from step 2 to 3? Again, you're always saying, how am I getting from one place to the next? What's my reason? Well, I have 5x equals 20, and then all of a sudden I have x. So we're actually getting rid of the 5, and the inverse operation of multiplication is division. So we're actually dividing the 5 out. So this is actually division property. We're using basically the idea that we divided both sides by 5. And here we go, we're done. We finished our proof. Okay, now this is a pretty simple proof. We're going to get more complex proofs, but make sure you have this written down. All right, we're going to take a look at just giving some reasons behind certain things. So we're going to go ahead and slide this away, and we're just going to look at some reasonings. Okay, so let's name properties. Okay, so here we have one right here. It says angle the measure of angle A equals the measure of angle S, and the measure of angle S equals the measure of angle K, then angle A equals angle, and that's a K. It kind of looks like a C, but angle K. This is actually a perfect definition of transitive property. If you go back and look at the definition for transitive property, it's very similar to the law of syllogism. Okay? In fact, that's where it gets its root from. So let's just give some numbers behind this. If A equals S, let's just say A equals 50 degrees. Okay, well if A equals 50 degrees, that means S equals 50 degrees. Well, we have S again, so S is also 50 degrees. That means K is 50 degrees. Do you see how A and K are now related to each other? Now again, I just came up with 50 arbitrarily. We didn't need to keep that, but that was just to show that this would make sense. So this is called transitive property. I'm translating information from one item to the next. Okay? Again, make sure we're writing down these examples. Number 2. My question is, how am I going from here to here? Just like we did in that proof earlier. Okay? Well, I have 3x plus x plus 7 equals 23, and then I become 4x plus 7 equals 23. Okay, well, we can take a look through our properties, and I'm looking at my properties, and I'm saying, okay, what is it? Is it addition property? Am I adding something to both sides? Not really. I'm adding the x's together, but I'm not adding them to both sides. Is it subtraction? No. Multiplication? No. Division? No. Reflexive? I don't even know what reflexive is. It looks like reflexive is just one thing equals itself. Symmetric? A equals B, then B equals A, so it's kind of like a mirror. That doesn't seem like it's right. Transitive, A equals B, B equals C, then A equals C. No, that's what we just did. Substitution property. A equals B, and then B can replace with any expression. Let me take a look. Is it true that this could be replaced by that? Could 3x plus x be replaced by 4x? And the answer is correct, yeah. So this is actually a perfect example of substitution. And this is where I'm going to start spelling horribly, so I better double check. Substitution. Don't want to look too dumb here. But this is our substitution property. So I went from 3x plus x to 4x. I substituted 4x in for 3x plus x. Alright, moving on. 3, we get 3 and x plus 5 in parentheses equals 9, and then we get 3x plus 15 equals 9. So we should recognize this as our distributive property, right? We're putting these in here. So from here to there, we're using distributive property. Okay. Number 4. Okay. AB is congruent to AB. This one seems really stupid, but why would we actually say two things are congruent to each other? I mean, it seems kind of obvious. I'm never going to say Mr. Smith is Mr. Smith. It seems kind of silly. But we want to give a fully understandable version of what's going on. So if you ever see something is equal to itself, we're just talking about reflexive. Okay, reflexive property. It's reflecting back the exact same thing. Okay, that's why we can call it reflexive property. So it's reflecting back. AB's on one side, what's on the other side? AB. If I look in the mirror, I'm going to see myself. Okay, so they're congruent. Number 5, very similar. These two get mixed up a lot. Angle E is congruent to angle T, just as T is congruent to angle E. This is not reflexive property. It seems like it could be, but this is actually symmetric property. These two are symmetric. We can say either or, either direction, and this will work. So this is what we like to call symmetric property. Okay, so we're going to get into proofs this chapter. Obviously, they're not very scary. The hardest part about proofs is just knowing a lot of the reasons and then applying them. Okay, but as you can see, a lot of this is pretty straightforward and pretty easy and manageable. So I hope you enjoyed the video. Hopefully it wasn't too tedious, and we will see you tomorrow.